Okay, mathletes, let's continue answering your week 3 worksheet on illustrating rational algebraic expressions. And this time, we're going to answer letter C. Find every value of the variable that makes each rational expression undefined. Okay, so when we say undefined again, the value that could make our denominator equal to 0. And of course, you are going to show all your works, or you're going to provide your solution. You have to take note that in mathematics, that's the most important um, part, your solution. And you're going to express your answer in set notation or interval notation. Um, the first method we can use to determine the possible replacement set, or to determine the possible replacement set that is not possible for the variable in the denominator, is by observation, just like in number 1, x minus 3. So we can tell right away what number is not possible. So what number um, that could make the denominator equal to 0? So we know for a fact that if we're going to subtract the same number, that makes the value equal to 0, and that is 3. And 3 minus 3 is equal to 0. But how are we going to do that algebraically? And how are we going to express our answer in a correct form, or in the correct form rather? So to start with, let us have problem number 1. Given 3 over x minus 3. So to determine which value can make our denominator equal to 0, so our concern here is only the denominator. So disregard the numerator. Okay, you have to disregard the numerator. So what are we going to do with our denominator? So simply, we're going to equate the denominator to 0. Okay, that's what we are going to do. So x minus 3, so we have x minus 3 equate to 0. That means equal to 0. And then we are going to solve for x here. So x is equal to, if we're going to transpose negative 3 to the right side, that becomes positive 3. So x therefore is equal to positive 3. So as I've said earlier, you have to show all your works, because I'm going to give points to your solution. Okay? And this is 1 point actually. So the next time, as I have observed, many of you have answers or final answer, but there is no solution or solvings. So I won't consider that next time. Okay? So next time, you have to provide your solution. Okay? So we have now x is equal to 3. This is not yet the final answer, because according to the problem, we are going to express our answer in set notation or interval notation, right? Here. So set notation, um, set notation or interval notation. So set notation is if you can express your answer in interval notation, that's good, but it's okay if it is in set notation. Okay, so x is equal to 3. So how are we going to express this in set notation? That means, um, let's make some space here. Okay, so all we have to do is we have set of x such that x is any element. So any element, or you can see it, the symbol, sort of letter E, any element of real numbers. So R actually represent all real numbers. So any element of real numbers, pwede kahit anong numbers, provided that x should not be equal to 3. Okay? Kahit anong number pwede sa replacement set, maliban lang sa 3, except 3. Why? It's because if we're going to substitute 3 here, sa 3 minus 3, this will be 0. And we know for a fact that any number divided by 0 is undefined. Okay? It will make our rational expression meaningless. That's it. So any number except 3. So x should not be equal to 3. So that is how we're going to um, express our answer in set notation. Okay? And interval. So for interval, uh, let's discuss first the two grouping symbols that we used in interval notation. So we have the parentheses and we have the brackets. So parentheses means the point is excluded. Okay, meaning hindi siya part ng solution. Kapag brackets, it is part of the solution, or the number actually, or the point is part of the solution. So kapag nasa number line tayo, if we have here the number line and we have here positive 3, meaning lahat ng number, all numbers to the left of 3 papunta dito are all possible solutions, and all numbers to the right of 3 are all possible solutions except 3. So usually we denote this by a hollow circle. Okay? So maliban lang sa 3. And how are we going to express this as in interval notation? So we have 3 and to the left, meaning all the numbers to the left are negative numbers. Okay? So we can have negative infinity, union of, okay, so that is and then 3 to the right are all positive numbers, generally positive numbers. So we have positive infinity. Okay, so these are the two possible ways wherein we can express our answers. So in terms of set notation, the first one here, and we have interval notation, the second one here. Well, either of the two, that is still correct. But of course, it would be a lot better if you know how to express your answer in interval notation. Okay, that's it for number 1. So let's erase this first. Then let's proceed to problem number 2. In number 2, we have a special product. So if you are familiar with the different special products, it would be easier for you to factor them out. Okay? Mas madali sa yung i-factor na yung mga special products kung familiar kayo sa mga iba't ibang klase, different special products. And in number 2, we have here difference of two squares. If we have difference of two squares, we only need to follow the pattern a plus b times the quantity a minus b. Okay? That's the only this is the only pattern in difference of two squares. We only need to determine the square root of the first term and the square root of the second term. So r squared, that means the square root of r squared is simply r. So that means the first terms both are, and copy the general form. So plus, here we have minus. And the square root of 4 here is simply 2. Okay, that's it. So we have the quantity r plus 2 times the quantity r minus 2. So again, after factoring the denominator, equate the denominator to 0. So we have r plus 2 times the quantity r minus 2 equals 0. Wait, let's erase. We only have limited working area. Okay, so we have here r plus 2 times the quantity r minus 2 is equal to 0. Okay, and after equating the factors to 0, equate each factor to 0 again. So we have r plus 2 is equal to 0, the first factor here, and r plus 2, and solve for r, or the variable. So we have r is equal to, if we're going to transpose positive 2 to the right, that becomes negative 2. And since we only have two possible answers here, so we may denote this as r sub 1. And the next one is r minus 2 equals 0, and r is equal to, transpose negative 2 to the right, so negative 2, this became positive 2. And we have here r sub 2. That's it. So that means there are two possible values here, negative 2 and positive 2. Now, how are we going to express this as set notation? Okay, in set notation rather. So we have set of r such that r is any element of real number provided that r should not be equal to positive. Okay, we can use the double sign. Positive, negative 2. And then close parentheses. Close braces, I mean. Okay, that's it. Okay, kahit set notation lang, okay na yan. And we will discuss interval notation if we still have time. Okay? So that's our answer for number 2. Set of r such that r is any element of real numbers provided that r should not be equal to positive and negative 2. Okay, and let's proceed to our next problem, number 3. Oh, in number 3, there is a typo error here. Okay, I made some mistakes here. Supposedly this is positive. Yes, supposedly this is 4q squared minus 17q plus 15. Because if it is negative, I think it would be impossible to factor the polynomial out. Okay, so it is not counted actually when I check your work. But for your benefit, assuming that this is positive 15, let me show you on how to factor this out. Okay, so in this kind of general trinomial where the numerical coefficient of the squared term is greater than 1, okay, we can actually multiply the two here, 4 and 15, so that would give us 60. That means we're going to look for factors of 60 that when added is equal to negative 17 here. So take note that the middle term is negative and the last term is positive. That means both factors are negative. Okay? Both factors are negative. So I think I've already discussed this method in simplifying rational algebraic expressions or factoring polynomials. Okay, but let me discuss this once more. So again, we are going to make two empty quantities outright, and we're going to copy 4q. So 4q, and as I've said earlier, we already corrected this last term. It should be positive, and the middle term is negative, so that means both factors are negative. And we are going to look for factors of 60 that when added is negative 17. So in this case, we can actually use the factor 3 or factor, yes. So let's get 4 and 15. Then 4 and 15. So 60, we have 4 and 15, and 4, 2 times 2. So factor 3, prime factorization method. So all the factors must be prime numbers. So we have 3 and 5. So from here, we are going to look for the possible combinations of prime numbers that would give us negative 17. And the possible factors here is 2 times 2 here. So we have 2 times 2 times 3. So we have 12 times 5. Okay? So all the factors here when multiplied will give us 60. We are only looking for possible combinations for the middle term, which is negative 17. So we have 12 and 5. Okay. So both factors are negative, so meaning negative. A negative 12 plus negative 5 will give us negative 17. Okay, that's it. So that means we have 12 and we have 5. Okay, and over, so whatever numerical coefficient we have here, so let's divide everything by 4. And then in our numerator, look for any factor that can be factored out by GCF. And we have here 4q minus 12. So there is a common factor which is 4. Removing that, so we have q minus 3 and 4q minus 5. There is no common factor, so copy 4q minus 5. That's it. Over 4. So our goal here actually is to cancel the denominator, whatever denominator we have. So that is why we remove the common factor in the numerator. So since the process in the numerator are all multiplications, so meaning we can do the cancellation method. So we can cancel this out. Over 4. So cancel 4 here. So that means the remaining factors are q minus 3 times the quantity 4q minus 5. Okay, that's it. So this is now the factors. So q minus 3 and 4q minus 5. And then what we're going to do is to equate these factors to 0. So we have I'm sorry. Q okay, we have q minus 3 times the quantity 4q minus 5 is equal to 0. Then equate each factor to 0. That means we have q minus 3 is equal to 0. And solving for q, transpose negative 3. So that is q is equal to 3. And since there are two possible values of q, so let's denote this as q sub 1. And another possible factor is 4q minus 5 is equal to 0. And we have 4q is equal to transpose negative 5 to the right. So we have 5. Then divide both sides by 4 here. So q sub 2 is equal to 5/4. Okay. Then So 3 and 5/4. Expressing our answer in set notation, we have set of Q such that Q is any element of real numbers provided that Q should not be equal to 3, and we can use and 5/4. That's it. Okay, so that's for number 3. Then let's have number 4. So this is quite easy. The numerical coefficient of the leading term is simply 1. So let's make two empty quantities here. Okay, and automatically equate to 0. So factors of 24 that when added is 14. So there are only few factors of 24 that when added is negative 14. So we have 6 times 4, 8 times 3, 12 times 2, and 24 times 1. So take note that 24 is positive and the middle term is negative. So that means both factors are negative. So first term, both x. So if these are all negative, so negative 6 plus negative 4, negative 10. It will never be negative 14. So not possible. 8 and 3, so negative 11. So not possible as well. 12 and 2, both negative. So correct. Negative 12 and negative 2 when added is negative 14. So we have negative 12 and negative 2. So this is by trial and error method. So after factoring the denominator, equate each factor to 0. So we have x minus 12 equals 0. So x sub 1 therefore is equal to positive 12, and x minus 2 equals 0. X sub 2 is equal to positive 2. Okay? Then, in set notation, we have set of x such that x is an element of real number provided that x should not be equal to 12 and 2. Okay, that's it. So that's for number 4. Okay, and for our last problem, so let's erase this. For number 5, this is quite easy. We have we have 6m plus m squared equate to 0. Then look for GCF. So the common factor is m. Removing that, we have 6 plus m is equal to 0. Okay, and equate each factor to 0. So we have the outside factor m equate to 0. So we have m is equal to 0. So m sub 1. And the other factor, 6 plus m equal to 0. So transpose 6 to the right, so we have negative 6. Okay, and in set notation we have set of x such that x is an element of real numbers provided that m should not be equal to 0 and negative 6. So that's it for finding the value which could make the rational expression undefined, or the other term for undefined is meaningless. Okay, I hope you learned from this discussion and try to review, since this will be included in your summative test. Okay, have a good day.